So today we're fixing a problem for a customer of ours. So the customer brought this in, this linear bearing here, and then this is the adjustment, and it was all sheared off all the way around. Cast iron. The customer needs the machine up and running as fast as possible. The customer brought this piece in. It goes to a machine. It's a jack. It raises up and down. The part right in front, right there, that's a linear bearing, and then this is the adjustment piece. And they over traveled the machine and sheared off the housing. This is a typical kind of job here for us every day. Is we get an odd problem and we're set out to come up with a quick and efficient way to get them back and running again. So the task today is to come up with a way to get this working for him while he awaits a new part, and maybe if we can do a good job, we could even replace the part entirely. Let me know your opinions in the comments below. If you've got a good idea or suggestion on how to approach this, I'd love to hear it. For now, I'll just show you what I intend to do. So this bracket was right there, mirrored on both sides. He only needs these 2 bolt holes. What I'm gonna do is machine, since it's cast iron, and the bearings, I don't want to get into the bearing assemblies for welding or brazing. I'm going to machine a flat right here and a flat over here. I have enough material in the middle there that I can drill and tap it. So I'm going to make a piece out of solid flat bar that will come up and over here, and then give him that ear to mount to that's missing right here, which will then be bolted into the side because it's cast iron right there. There's not a lot of load on this. It was simply an operator error that caused this to over travel. Let's take it to the next step and we'll see what happens. We're gonna do our best to find that hole using that reference that we just got there. Now, because this piece is broken off, we're not gonna get very accurate, but we're gonna do the best we can to determining where that hole center is relative to this end here. We've got 0 to here, and then 0. We found our 0 point over to here. We're gonna drill and tap this for 2 flathead bolts to give it the support for the new steel piece that we're gonna put back in. We're gonna start milling down the mild steel blocks to put into our part. And now we're just gonna square up the bottom. We just got done making the L brackets, counterbored and recessed, so this will sit nice and flat and still allow the bolt and the nut to be tightened on this side. So we just need to drill these holes. So preliminary fitting up, parts look like they're going to fit great. There's the left side, and we'll do the right side. That goes on there. All we need to do is drill the top bolt holes to replace this piece that broke off. Okay, so we got the part mocked up. Now we just have the 2 holes to do at the top. To try and determine the hole centers for the 2 ears, it's going to be tricky because all we have are just parts of this broken casting to try to figure that out. So what I want to do is find some locating geometry, like that top radius there. I know it's concentric to this. We got the holes drilled. Time to put it all together and see if it fits. Here's the finalized part with steel mounted ears to salvage this cast iron bearing housing. This should get our customer's assembly line going while he awaits the arrival of a new part, which is weeks and weeks out. There's many ways to solve a problem. Every day is a new challenge here. One of the best parts about this job. If you guys have suggestions or any other ways or ideas that you would go about it, let me know in the comments. Love to hear them. Overall, I'm happy with the end result.
Shout out to College Machine. The manufacturer said it would take 8 weeks to replace this part, and they did it in 24 hours. This wasn't the first time they've saved our necks, and I'm sure it won't be the last.